Pico Mountain in the Azores is about 900 miles west of Portugal in the North Atlantic Ocean. It's remote and the peak sits 7,713 feet above sea level. But overhead, a suite of global aerosols pass by. Soot from fires in the Yukon, dust from windstorms in the Sahara Desert, even tiny salt grains from crashing waves in the remote ocean. These remote aerosols, and how they get transported, have become an important topic in atmospheric science because they interact with sunlight and with clouds, which are both wild cards of atmospheric models. That holds true whether we're trying to predict the weather, better understand climate systems, or assess the health impact of aerosol pollution. And aerosols with long-range transport may be skewing these already complex systems, potentially affecting rainfall, cloud cover, pollution dispersion, and how much light clouds reflect. In particular, short-lived brown carbon may be a crucial piece in understanding how changes in aerosol makeup may impact atmospheric processes and the energy balance of the planet. Short-lived pollutants only reside in the atmosphere for a few weeks, but they can spread around the globe. That's why Pico is the perfect place to study them. The island mountain is the tallest point in the North Atlantic for thousands of miles around. Coupled with a low-altitude marine boundary layer means the peak often hangs out in the free troposphere. The clouds that form below show a clear separation between the atmospheric layers. Thousands of feet above the ocean, just below the mountain island's peak, sits the Pico Mountain Observatory. The researchers use numerous instruments, and they have to hike a lot of them in, or hike them out for repairs. When the weather permits, they have a couple of backpack versions of the instruments to track data up and down the mountain. Take this nephelometer. It measures how much light bounces off of aerosol particles, gauging how much sunlight these particles will reflect back to space, which has a cooling effect on Earth. And this photometer measures how much sunlight is coming through the atmosphere. There's also a particle counter that measures how much is in the air. The team also gathers info through a pressure, temperature, relative humidity data logger. These are measured up high at the observatory too with a weather station. Inside the observatory, more discerning equipment like atherometers and optical particle counters help separate out what kinds of particles make their way to Pico. Other instruments measure gases like carbon monoxide, emitted together with the particles, as well as other atmospheric compounds like ozone. High-volume particle collectors gather samples to be brought back to Michigan Tech. Back on campus, the researchers delve into the molecular and atomic nature of the particles and their shapes, using scanning electron microscopes, transmission electron microscopes, and mass spectrometry. As weather and climate and pollution shifts, so do the clouds of Pico. They carry tiny clues locked in the complex shapes and chemistry of aerosol particles.